Now, I want to talk about a concept which I feel is extremely important as far as the design process is concerned. And this is something we call design restrictions. Now, as you know, in most programs, when you want to get something designed, what you typically say is that you use sections of that particular family, for example. So let's say IPE family, and the program will go through all the members of the IPE family and find one solution for you in that design loop. Now, in Comosys, we've gone a few steps beyond that, and we've created this concept of design restrictions. And what design restrictions you can create as many as you want, and then you can assign those to any element which you want. But what does a design restriction look like? So let me open up this existing design restriction. And what this is saying, you can give it a name. So I can call this beam or column or vertical bracing of bottom floor or beams up till the second floor. As many names as you want, as many design restrictions as you want. But in each of them, you can put multiple families to begin with. So you can say that I want you to try the HEA family. And then if it doesn't work, go to the HEB family. And if that doesn't work, go to the YP family. If that doesn't work, try this one. And if that doesn't work, try this one. And for each one of those, I can have further limitations. I can say that when you're trying the HEA family, you should only use those with a height of greater than 300 millimeters, for example. And since I'm designing particular beams, I want the flange width to be greater than or equal to 150 millimeters. So while you're going through the entire family, make sure you're sorting out these constraints. And you can also go into the manual selection and say that, okay, when you're doing the HEA family, don't check for all the available HEAs, but check for these ones and these ones and these ones, and don't check for the rest. Well, this is a very powerful feature. And you can also tell it to limit your lambda. For example, if this is not for beams, but say for vertical braces or horizontal braces or columns, you can limit the lambda if you want, the buckling length related lambda values. And you can, but one other thing you can do is, for example, if you're doing it for vertical bracing, you can create a design restriction. Let's create another one, for example, and call it VB. And you can say that when you're designing the vertical bracing, I want you to try single angles. So you double click on that, but then you want to try your twin profiles as well. So for that, what you do is you go to your twin section over here and you say, I want you to try back-to-back angles after checking single angles. And if that doesn't work, I want you to try cross angles. And if that doesn't work, I want you to try back-to-back channels. And if that doesn't work, try face-to-face channels. And if that doesn't work, I want you to come back and do an HEA section for the vertical bracing. So you can have a complicated design restriction set up like this. And for each one of them, you can have limitations on the HPST values. For the cross angles, you can say when you're doing that, put a distance of 12 millimeters between them. For the back-to-back ones, you can say you can have the same distance depending on your detailing requirements, etc. So you can have very complicated scenarios, and you can also have this feature called a use priority. Now, what that means is that it will first go through the angles. It'll then try the back-to-back angles, and then the cross angles, and then the back-to-back ones, and this and that. But if you remove this flag from here, what it will do is it will put all these families, all the angles and the back-to-back angles and the cross angles and the eye profiles into one bag, and it will sort them according to their weights, linear weights, weight per unit length. And then so it could be that it tries an angle, and the next thing it tries is an HEA section, and the next thing it tries is a back-to-back angle. They will be sorted according to their weights. But if you put the priority back on, what that will mean is that it will basically check them one by one. Now, this is useful, for example, if you're doing, for example, if you had a beam. So let me just remove these. Let's say you had a beam type of a case in which you wanted to check for INP as well as HEA. Then you know that if you tell it to go all the way to the end of the INP section and then come to HEA, this might not give you a very good result. The reason being because INP profiles are don't have wide flanges. And if the beam had a little bit of M22 in it, maybe you would find a solution right at the end of the INP series, which would be a very uneconomical solution. So instead of doing that, you remove the priority and you say that you mix them up and whichever one works. So maybe it'll try the smallest INP and then it's going to try for the HEA one, and that might work according to the weight. So these are very powerful features, what we call design restrictions. And what you can do is you can create as many as you want, and then you can select any member and you can go to the design tab, and inside you can say that this element will be designed according to this design restriction. And you can do that with the multiple selection as well. For example, you can select the entire, all the beams over there, and you can say all these will be, or what you can do is you can go like that and you can say enter, or let me just turn on the fly filtering, say go to profiles, turn according to beam groups and say only select the beams. And then you can say, I want these beams to be designed according to this design restriction. And these are this is a very powerful feature, which will really clean up or make your design process very well. Now, once we are done with the analysis, we can proceed with the design. And we have these options of either checking elements or designing elements. These are two different options. You can check a particular element, which would be check selected, or you can check all, or you can check a particular subset, or you could design the selected elements, or you could design the entire structure. And so let me just what's the difference between checking and designing is that what checking will do is it will take the existing section. So if this is the existing profile, for example, it has a certain size. And what check means is just use the existing section and do all the design checks at all the stations. Right now, if I were to select this element, the analysis has been done. But if I were to say, show me the design data, it's empty. The element has no design information. It's just been analyzed. But if I were to select it and say, check selected, then immediately the program performs a design check on that element. And after having done that, I can go and check the design data. And this time the design data is filled. And you can see over here your final stress results. This number should be less than 1. Basically, the summation of your axial forces plus your bending moment and your bending 3-3, the total should be less than 1. Right now, it is less than 1. And it'll give you the exact locations. It'll say that the most critical combo was this one. At a location of 0, the axial force was this much, the bending moment was this much, etc. Your lambda or inertia parameters are given over there, your K factors, your L unbraced lengths, and your design related variables, and the final analysis. And it will also do over here your shear checks as well as your deflection checks. So it will do the analysis, but this is basically a design check. So it's not really designing the element, it's just checking it with the existing one. Whereas the option of designing it would mean that, okay, you don't change the profile, keep it as it is. Obviously, to change the profile, you would need to unlock the model, but you assume as if the loads will remain the same, whatever the current loads are, but you find me a section which will work for the case. And how will it find this section? It will use the design restrictions which we had provided. So for example, this particular beam might have some design restrictions. Let's go to the design tab. So it has a design restriction called, it has a name over there. And this particular design restriction is over here. We can go in there and this says check for HEA, check for HEB, YP, IP, and this and that. So if you instead of saying just check all, if you check the selected one, if you say design the selected one, it will go through this design restriction and find the appropriate section for you. So let me just do that. Let me double click on that. Right now we just did a check, but if we were to select this and say actually design the selected one, then what it will do is it will suggest a section for you. It will tell you that this if you use this section, then this will give you the optimum result, and then you can modify the existing section according to that, and there are very quick ways of doing that and replacing the thing for the whole building, etc. And we will obviously talk about those as well in a minute. Now, instead of checking a particular element, let's just go to this check option over here and say check all. and this will tell the program to check all the members of the entire building. So let's just press that. And very quickly, it goes through the design of all the elements and all the stations and all the load combos. And in a few seconds, it's completed. Once the check has been performed, we can turn on the color coding from here. And immediately on the screen, you can see that the elements have been color coded according to their design ratios. And you can set those colors up, of course, in your settings by going over here and defining. You can add to these ranges. You can make them more refined, and you can also limit the color coding according to, because obviously when an element fails, it can fail according to your capacity ratio, or it can fail according to your lambda criteria. It can also fail according to your deflection criteria in the 2 and the 3 directions, or it could fail according to your shear criteria as well. You can choose which criteria to consider when you're doing the color coding, and that's a nice advantage to have. But anyway, coming back to the subject, it color codes on the screen, and you can see that the elements are either green or blue, which is okay, and the red ones are the ones which have a problem. So if we zoom in there and select this one and say, okay, this is failing for some reason, and I want to check the design data. So the axial and bending components seem to be less than 1. That's okay. The shear check is fine, but there's a warning over here for the deflection check. It's not really passing by a big amount. 0.011 is slightly bigger than 0.010. So maybe you can ignore that, or depending on what you want to do. Once again, you can go to other parts of the building. There's another one failing over here. You can go and check the design data. Everything seems to be okay as far as axial is as far as stresses are concerned. Once again, there's a deflection failure. It's like almost double what it should be. 0.04 is greater than 0.02, so you need to do something about this. So this is a very nice and convenient way to check your design results. If I was to say that I'm not really worried about deflections right now, just show me any stress failures for the moment. What I would need to do is I would need to go to my settings, go to my design ratio colors, and say don't show me the color coding according to deflection criteria. And the moment I do that, these elements also turn green, and now only the stress checks and the shear checks are being done.